Now let's walk through two different scenarios of setting up your airfoil profiles. In the first option, we'll use a freehand approach where we create one spline, mirror it, and then generate a profile from it. In the other, we'll explore a parameterized custom block that allows you to enter a 4-digit NACA code and outputs an airfoil profile on its own. Something to keep in mind here is that we're modeling with implicit bodies and scalar fields, so the result of this section needs to be a profile with its own sign distance field. That means that later on, when we want to remap or apply other field operations to it, we won't run into any issues. Let's start with our more freehand approach, where we create a spline by control points and then mirror that spline. To our notebook, we can add a spline by control points block. Then we can add any number of points that we want. I'll add a point list. And we'll include 5 input points. Let's make our leading edge fall right where our root point was in the beginning. We can take that root point and drop it in as control point number 1. Then maybe for our next control point, we can drag it up in the Z direction a bit. Next, maybe we'll adjust the X and the Z. We'll do the same for the next point. And then maybe our final point, or our trailing edge, can take into account our root chord length. So we can right-click, and maybe convert this to a point block, and use our root chord length as our X. That'll place this final point here at the end. Viewing this from the side, we'll have a point list that looks something like this, and a spline that turns out like this. Now say we want to take that spline and mirror it. We can build that out together, or we can just use the custom block that we've provided. I'll pull in the mirror spline custom block and add it to my notebook. And if we right-click and open this up, we can see what's going on in here. So we have a spline that we input and the plane that we mirror it across. And what this block is going to do is take those control points out of your spline and translate each of them by some distance. To define that distance, we use the evaluate field block, where we take the field of the plane and evaluate that field of each of those points. Since the field is just an SDF of the plane itself, each of those evaluated values just represents the distance of the points from that plane. So then when we translate those points, we can just take the unit vector of that plane's normal and drag each point in the negative direction. Here we use a multiplier of 2, the first instance pulling the points back to the plane's surface, and the second instance pulling them that same distance opposite the plane. Finally, we take those translated points and feed them into a new spline by control points block to generate our mirrored spline. Keep in mind here that we'll also retain the degree of our initial spline. So if we come back here into our original notebook, we can make that spline by control points into a variable called top spline, drag it into our mirror block, and generate some plane. So viewing this from the side, we see that we have our initial top spline that gets mirrored. I'll take this mirrored spline, right-click to make it into a bottom spline variable. And then if we view the field of each of those splines, we see that we have these unbounded curve fields on the bottom and the top. So our last step here to create one cohesive profile with a sign distance field is to add the block profile from curves. drag our splines into our curve list, and view our resulting field. Now we have this fully enclosed profile with that negative on the inside, positive on the outside, and this infinite field in the y direction. I'll right-click and make this into a variable called airfoil profile. So you can go about making your own airfoils, creating your own splines, and making your own profiles. Or feel free to explore or create your own parameterized custom blocks to generate profiles on your own. One example you can download in the example files is this NACA 4-digit airfoil creator that generates these NACA profiles depending on a 4-digit code that you input. You can play around with this and see the types of airfoils you can create. I'll right-click and make this into a variable called NACA profile. And now we're familiar with these two different approaches.